This is the second video about oxidation numbers and redox. Here are some of the key points that we covered in the first video. As it says, an oxidation number is a measure of the number of electrons that an atom uses to bond with atoms of another element. So it's kind of linked to the idea of charge, but if we remember, not all compounds are ionically bonded. We can have covalent bonding. So oxidation number makes more sense to use for this type of compound. In the bottom table are some things that you have to learn. You just need to know these. A compound is made up of different elements joined together. And the sum of all of the oxidation states, or oxidation numbers, comes to 0. The oxidation state of any element is 0. For example, Na, the oxidation state is 0. Cl2, the oxidation state of the atoms in Cl2 is 0. S8, the oxidation number of each sulfur in S8 is 0. So if all of the atoms are the same, it does not matter how many atoms make up the molecule, the oxidation number of the element is 0. The sum of all the oxidation states in an ion is equal to the charge on that ion. When oxygen is inside a compound or an ion, its oxidation number or oxidation state is -2. That is super important. Similarly, the oxidation state of hydrogen in compounds or ions is +1. The oxidation numbers of group 1 elements and group 2 elements, when they are in compounds or ions, will be +1 or +2 respectively. The last point is a bit more vague, this one. The oxidation state or the oxidation number of group 7 elements can change even when they're in compounds. But you can often assume that it will be -1 unless you're being asked to find that out. If the question is more open-ended, it's something that you may need to calculate. You should have had an opportunity to answer these questions, and that's what we're going to review. Looking at the first one, potassium, K, there's nothing else there, there's just K, so it's just an element. So the oxidation state, by definition, is 0. Similarly, B, bromine, Br2, the only thing which is present is bromine. It doesn't matter that there are 2 of them, we only have bromine present. So the oxidation state, 0. Now the next one, calcium fluoride, CaF2, we've clearly got 2 different things, and each of them will have its own oxidation number. Calcium is in group 2, so it has an oxidation number of +2. Remember, we always put the sign before the number when discussing oxidation numbers. Now, calcium fluoride, overall, there is no charge on calcium fluoride, so the sum of the oxidation numbers must equal 0. The calcium, as we've just said, is +2. So we need to then add 2 lots of fluorine, and that sum will come out at 0. So 2 fluorines will be equal to -2. Each fluorine will be equal to -1. And we're interested in the oxidation number of each individual atom within the compound or the ion. So similarly, aluminium oxide. This time, we've got 2 aluminiums and we've got 3 oxygens. Now remember, by definition, oxygen is -2 when it's inside a compound or an ion. So I can see that 2 lots of aluminium plus, well, there's 3 oxygens, so that will add up to -6, will equal 0. 0 because it's a compound. There's no charge on it overall. So the 2 aluminiums will be equal to +6. So each aluminium will be equal to +3. Now the last one, NO3-, we're going to work out in a similar way. We've got nitrogen, and we're going to add on 3 lots of -2 because we've got 3 oxygens. Each oxygen has an oxidation number of -2. But this time we can see we've got a minus sign on the ion. So the sum of all of the oxidation numbers will equal -1. So N -6 equals -1. To simplify that, N will be equal to +5. So N is +5 and the oxygen is -2. Jumping ahead slightly, we're going to look at the answers to question 3. These are slightly more complicated because there are more atoms present. In the first one, NaClO3. Sodium's in group 1, so we'll have an oxidation number of +1 when inside a compound or ion. The oxygen, -2. These are the things that you've been told to learn. So, in order to work out the chlorine, I'm going to have a +1 from the sodium, plus my chlorine, plus 3 lots of -2 for the oxygens, which is -6. And because it's a compound, that will add up to an oxidation number of 0. So chlorine -5 equals 0. Chlorine equals +5. Now, to begin with, it may help to set out your working formally in the way that I've just been demonstrating. As you become more competent and more experienced with these types of questions, you'll find that you start to do these much more quickly and do much more of the processing just in your head. In the next one, we've got Na2S2O8. We know that sodium is +1. We know that oxygen is -2. So to work out the sodium, I'm going to have to work out the sulfur, I'm going to do the following sum. There are 2 sodiums, so that adds up to +2, plus 2 sulfurs, and we've got 8 oxygens. Each oxygen is -2. 8 times -2 gives me -16. There's no charge, so that will come out at 0. So my 2 sulfurs -14 equals 0. So sulfur plus 14, the sulfur will equal +7. Let's have a look at C, because this is an ion. Potassium, group 1, so +1. Oxygen, inside a compound or ion, -2. So to work out the manganese, I've got my potassium, which is +1, plus my manganese. Well, I've now got 4 lots of oxygen, so 4 lots of -2 gives me -8. And that needs to add up to the charge on the ion. And the oxidation number of the ion is coming out at -1. So this time, manganese -7 equals -1. So the manganese is going to be equal to +6. In this next section, what we have to do is use oxidation number rules to work out the formula of the ion. Now this is more simple than it sounds, because we've got the presence of Roman numerals, and the Roman numerals tell us that on the chlorate ion, which has a charge of 1 minus, the chlorine has an oxidation number of +3. The Roman numeral tells us the oxidation number. So chlorine is +3. So what we have to do is think, well, +3, adding on, well, what we don't know is the number of oxygens in the chlorate ion. So I'm going to have X, where X is the number of chlorines, multiplied by the oxidation number of the oxygens. Might have said that wrong. X is the number of oxygens multiplied by its oxidation number of -2. And that will equal -1. So I've got a chlorine with an oxidation number of +3. I don't know how many oxygens I've got. That's the unknown number X. Each oxygen has an oxidation number of -2. And that's got to all add up to the overall charge on the ion. So +3 minus 2x equals -1. So simplifying that, minus 2x will be equal to -4. So x will be -4 divided by -2. X will equal 2. So that's telling me how many oxygens. So I know I've got chlorine, 2 oxygens, and then the minus sign. So the formula of the chlorate 3 ion will be ClO2, 1 minus. Let's have a look at the next one, just to check that we understand what we're doing. This time, the Roman numeral 7, it's really important we know our Roman numerals, tells us that the chlorine has an oxidation number of +7. So I've got +7 plus, well, I'm going to have an unknown number of oxygens. That's what I'm trying to find out. Each oxygen has an oxidation number of -2. So I'm going to have -2 times by the number of oxygens. That's what X is. I don't know what that is. And that will be equal to the charge on the ion, -1. So trying to simplify that, -2x will be equal to -8. X is going to be -8 divided by -2. X will be equal to 4. So if I've done all my arithmetic correctly, the formula will be Cl. O, we've just worked out that there are 4 of them, and the charge is 1 minus. Finally, let's have a quick look at the phosphate 3. So the phosphorus has an oxidation number of +3. So I've got phosphorus, and I have in there an unknown number of oxygens. That's what the 8 is telling us. Each oxygen has a charge of -2, and that will come out with an overall charge of 3 minus, so the oxidation number -3. So if I simplify that, -2x is going to be equal to -6. X will be -6 divided by -3. X will be equal to 2. So it's going to be PO2 3 minus. Sorry, Minus 6 divided by minus 2. Done that entirely wrong. Minus 6 divided by minus 2. X will be equal to 3. Always worthwhile checking your answer. So it should be PO3, 3 minus. Sorry about that.